All right, so we're going to go to section 4 of chapter 1, quadratic equations. We're just going to cover some problems that you're going to see in that section's homework. All right, so the first type is to solve quadratic equations by factoring. Remember that whenever we're trying to solve these quadratic equations by factoring, the first thing we want to do is set the equation equal to 0 or 0 out one side of the equation so that it's in general form. So a good example of this would be a problem for us to, we're asked to solve the quadratic equation x squared plus 7x is equal to 18. This is a side note, especially if you have the Casio. Remember, we're supposed to have a graphic calculator. If you have a Casio or the TI, you probably already have a program where you can plug in your A, your B, and your C. The most general form for the quadratic equation, ax squared plus bx plus c is equal to 0. This is where we get our A, our B, and our C from. So the number in front of the x squared term, A, the number in front of the x term, B, the number by itself of the constant term, C. All right. So back to our first type. If we're given this quadratic equation, one, we know it's quadratic because we see the highest degree is 2, or the highest exponent on x is 2. First thing we want to do is 0 out the equation. If we look at it, we have x squared plus 7x is equal to 18. First thing we want to do is subtract 18 from both sides of the equation. So now we have the quadratic x squared plus 7x minus 18 is equal to 0. All right. So now what we want to do is factor this quadratic. Remember, if we have a trinomial, which is a fancy word for saying we have 3 terms, x squared, 7x, and 18, negative 18 to be more specific, we want to find 2 numbers. Excuse me, if we have a trinomial with a leading coefficient of 1, we can jump straight into factoring. Looking for 2 numbers we can multiply to give me negative 18, that we can combine, add or subtract to get positive 7. Obviously, those 2 numbers are 9 and 2. We know 9 times 2 will give me 18. In order for it to be a negative 18, one must be negative, the other must be positive. In order for us to get a positive 7, the 9 must be positive, the 2 must be negative. Now, the 0 product property says that if we can take, each of these factors, set them equal to 0, and then solve for our solution. All right. So what we're going to do is take each factor. First one being x plus 9, the other being x minus 2. Set them equal to 0, and then solve. So our solution set. So negative 9 and positive 2. All right. So just a general idea of something good to know. When we have our factors, or we have the quadratic completed factor, the opposite of the number we see in our factor is going to be our solution. By that I mean we see positive 9 in one factor, negative 9 is one of our solutions. We see negative 2 in one factor, positive 2 is one of our solutions. All right. Any questions on that first example? Another type of quadratic we're going to see is one without a leading coefficient of 1. We're going to have a trinomial. And the very first number we see is not understood to be 1 this time. A good example of this is if we're given the quadratic 10x squared plus x minus 2 is equal to 0. All right. Now, unlike the last example, when we started with x squared, we actually have a number in front of our x squared here. There's a couple techniques that we can use to factor this completely. The method I usually use, the bust up method. Another professor showed me another way we can do these problems, and it seems to be a little simpler. The only thing is, it's not a lot of rationale behind it. It's kind of you just doing what I'm telling you to do, unless you've already seen it, and you can lean on what you've already learned from this factoring technique. So the difference between this example and the last example, obviously, is my leading coefficient. So what we can do is multiply my A and my C, or the very first leading coefficient, by my constant term. So the first step, I'm going to multiply by A, or in this case, we're going to multiply by 10. And we're going to rewrite it, forcing our leading coefficient to be positive 1. So now what started as 10x squared plus x minus 2 is going to become x squared plus x minus 20. And this is equal to 0.
So
Not cancel out, we're just kind of multiplying and bringing it to the end. Just so what we're really doing is manipulating the actual quadratic. This way we can make it quadratic that we're used to dealing with, as long as you remember that if we multiply by 10 and we come back in the end and divide by 10, essentially we've done nothing to the problem but change the way that it looks. All right, so first we're going to multiply by our A. This time our leading coefficient A is 10. Next up, we're going to factor it like we would in the other quadratic. So here we're going to look for two numbers. We can multiply to give me negative 20. And we combine to get positive 1. I'll say those numbers are 4 and 5. In order for us to get a negative 20, one of the signs must be negative, the other must be positive. In order for us to get a positive 1, the 5 must be positive, the 4 must be negative. All right. Now we're using this technique. When we multiply by 10, we factored it. We got to remember to go back and divide by that same 8. So in this case, we have to go back and divide by 10. Now, when it says divide by 10, we're really focused on dividing the numbers part of our factors by 10, and then we're going to reduce the fractions if possible. All right, so just like in the last example, the opposite of what we see is going to be my solution. So here I see negative 4/10. Obviously, that 4/10 can be reduced down to 2/5, but in terms of my solution set, if we see negative 2/5, positive 2/5 is going to be one of my possible answers. Here, 5/10 can be reduced down to 1/2, but we see positive 1/2, so negative 1/2 is going to be a part of my solution set. All right, so our answers here, 2/5 and negative 1/2. All right, now technically there's another way of doing this that has a lot more rationale to it, to where you're not just doing what I'm telling you because I'm telling you to do it, but it actually has a lot more steps. If you're interested in that, you just hang around. I don't mind going over there with you, but I think this is the most concise way of getting to our answer. All right, any questions on this example? All right, so if you're anything like I was, when you're taking this class, the first time you see this, it's new. So I think it'll benefit us to do this, another example like this one, where we have a trinomial with a leading coefficient other than 1. So in this example, we're going to have 6x squared plus 7x minus 3 is equal to 0. Yep. The way I want you to think of it, we have a quadratic, leading coefficients other than 1. First thing I want to do, multiply my A and my C. And we're going to rewrite it. So we have 6 times 3. We're going to make that last, on my constant term, 18. Remember the first thing we did here was multiply by 6. So now this becomes x squared plus 7x minus 18 is equal to 0. And now we can start factoring like we would in the other quadratic with a leading coefficient of 1. So we're looking for two numbers we can multiply to give me negative 18. that we can combine to get positive 7. Here, 9 and 2 will give me 18. 9 minus 2 will give me a positive 7. So that 9 must be positive. My 2 must be negative. So we multiply by 6, we factored it. You got to remember to go back and divide by 6. Keeping in mind, the opposite of what we see in our factors is going to be what's in my solution set. All right. So here we have a positive 9, 6. This obviously can be reduced to 3 halves. 3 goes into 9 3 times, 3 goes into 6 twice. We see a positive 3 halves, so negative 3 halves is what's going to be in my solution set. Here, 2, 6 can be reduced down to 1/3. We see a negative 1/3 in my factor, so positive 1/3 is what's going to be in my solution set. All right. Any questions on this example? Next type of quadratic we're going to see is a simple quadratic, or we can solve it by taking the square root. Take note that we will have 2 answers here. So we're given the quadratic x squared is equal to 25. This is our first example for simple quadratic. Remember to get rid of the squared term, or the opposite of squaring something is to take the square root. So we're going to take the square root of both sides. And because we're solving this for all possible solutions, we have to account for both the positive and the negative root for this radicand 25. So here, square root of x squared leaves me just with x, which is what we want. Square root of 25, we know that principal root is 5. Remember, we must account for both the positive and the negative, because 5 squared gives me 25 and negative 5 squared gives me 25. All right, so just to be clear, both 5 and negative 5 are my solutions here. All right, we also have to do this for numbers that are not perfect squares. A good example of that would be the equation x squared is equal to 29. Just like before, to get rid of that squared term, we're going to take the square root. That leaves me with x on the left-hand side. And because the square root of 29 cannot be broken down any further, and it's not a perfect square, the square root of 29 is my answer, but we must account for both the positive and the negative square root of 29. So just to be clear, that answer, square root of 29 and negative square roots of 29. Another simple quadratic that we can solve would be one of a negative radicand. A good example of this would be x squared is equal to the negative, or excuse me, is equal to negative 144. Just like in previous examples, to get rid of that squared term, we must take the square root. That leaves me with just x on the left-hand side, which is exactly what we want. The square root of negative 144. Remember, there is no real solution for the square root of a negative number, but we do have complex solutions. So we know the square, to get rid of that negative, the way we account for it, just like in the last section, is to pull out that I. This would be I times the square root of positive 144. But my answer ends up being 12i. Just like in the previous problems, we must account for both the positive and the negative when we're asking to find the solutions. So this answer is both positive 12i and negative 12i. Another type of problem you're going to see in this section is technically a simple quadratic. It'll be a problem like this one. X minus 8 quantity squared is equal to 24. All right. And just like before, to get rid of that square term, now take the square root. Whatever we do to one side, we must do to the other. That's going to leave me just with my radicand, or in this case, x minus 8. And that's going to be equal to both the positive and negative square root of 24. Now, while 24 is not a perfect square, it can be broken down further. And remember, the whole point is to simplify. Now, before we go ahead and break down that 24, we want to get the x by itself. Simplest way, add 8 to both sides. So now we have x is equal to 8 plus and minus 20. The square root of 24 is the same as the square root of 4 times 6. This is because 4 times 6 is 24. For those who need to see it. Like so. But we know the square root of 4 is 2, so that comes out of my radical. I got you. But that 6 still stays underneath my radical. All right. Now, keep in mind, this does represent two separate answers. 8 plus 2 square roots of 6, and 8 minus 2 square roots of 6. All right. Now, when you're doing your homework on the computer, at least, I think they do give you the option of that plus and that minus, but you do want to recognize that they do represent two separate answers. All right. Any questions on this one? We got one more simple quadratic in that section. In this example, it reads x plus 4 quantity squared is equal to 12. Just like in previous examples, first thing I want to do is take the square root of both sides. It's going to leave me with x plus 4 on the left-hand side, positive and negative square roots of 12. Now, while the square root of 12 is not a perfect, 12 isn't a perfect square, it can be broken down. Remember, 4 times 3 is 12. So we can pull out our 2 because we know the square root of 4 is 2. And we do want to get our x by ourselves, or by itself, excuse me. So we want to subtract 4 from both sides. It's going to leave me with x is equal to negative 4 plus and minus 2 square roots of 3. All right. Now I'm taking for granted that we know how to break down those radicals and that complex numbers we mastered in the last section. Remember, if you have any questions with that, you can take advantage of the office hours and just hang around at the class, come a little bit before. I don't mind going over it with you. All right. Any questions on part 2, solving those simple quadratics by taking the square root? The next technique, should I say, for solving quadratics would be solving by completing the square. All right. Now, some have seen this technique before. If not, just a quick reminder. The first step when we're solving by completing the square is we want to isolate our x terms or move the constant to the other side of the equation. So the first thing we want to do move constant. To the other side. When we're completing the square, what we're going to do is force our x terms that remain on one side to be a perfect square trinomial. The way we're going to do this is by picking a number and adding it. The way that we're going to find that number is by taking the coefficient of our x term, or the number in front of x, we're going to divide that by 2 and then square it. Now remember, with the quadratic, we're going to have an x squared term, we're going to have an x term and a constant term. First step, keep the constant to the other side of the equation. Second step, take the number in front of the x, divide it by 2 and square it. That's going to be the number that we add to both sides of the equation. This way we're manipulating the way that the equation looks, not changing the value of our answer though. So third step, add number to both sides. Now we are going to factor it, but remember, we're forcing this to be a perfect square trinomial. So you're going to see that it pretty much works out the same way every single time. All right, so we can save some steps on the factoring by recognizing the characteristics by completing the square. And the last step, we'll take the square root of both sides and solve. All right, now obviously the problems are going to change, the numbers are going to change, but these steps are going to stay the same if we're solving it by completing the square. A good example for this one, solving by completing the square, and then directions will tell you solve by completing the square. If we're given the equation, or should I say the quadratic, x squared plus 10x minus 20 is equal to 0. All right, so our first step, we want to isolate our x terms. I'll take the constant term, this time is negative 20, move it to the other side of the equation. So we're going to add 20 to both sides. It's going to leave me with x squared plus 10x. I'm going to leave a space because this is where we're going to add that number that we're going to generate by taking the coefficient of x, dividing it by 2 and squaring it. But it's going to be equal to 20 plus that exact same number. Remember, as long as we, or whatever we do to one side of the equation, we must do it to the other to keep it balanced. This does not change the value of x, but it does change the way the problem looks. All right. So remember, our second step, we're going to take the coefficient of x, divide it by 2, and then square it. That's how we're going to get this number that we're going to add to both sides of our equation. So we're going to look for that number, or that b term with the number in front of x alone. And we're going to generate the right number that make it a perfect square trinomial. So we're going to take that 10, divide it by 2, and square it. Remember, we got that 10 by taking the number in front of the x term. We know 10 divided by 2, it's going to give me 5 squared, or the number that we're going to have to add to both sides of my equation. It's 25. So we're going to add 25 here, and to keep the equation balanced, I'm going to add 25 to the other side as well. Now what we're supposed to do next is factor this perfect square trinomial, x squared plus 10x plus 25. So what we're really doing is looking for two numbers we can multiply to give me positive 25, that I combine to get 10. Those numbers are 5 and 5, and both must be positive. And of course, this is equal to 20 plus 25, which we know is 45. Now, by definition, anything times itself is squaring. So x plus 5 times x plus 5 is really x plus 5 quantity squared. And that's still equal to 45. But notice that when we're generating this number to add and make it a perfect square trinomial, we had positive 5 inside my parentheses. All right, that's always going to be what's inside my x term when we completely factor it. All right, so if it's positive 5 here, it's going to be x plus 5 quantity squared. That's going to be the completely factored way. We can skip all this factoring technique here if we recognize that fact. Now, had it been something like -6 inside this step here, then the completely factored form would be x minus 6 quantity squared. That's going to happen every single time by completing the square. This is why we're completing the square, to force it to be a perfect square trinomial. But now it's a simple quadratic, and we can solve it like we did in previous examples. To get rid of the square term, we'll take the square root of both sides. It's going to leave me with x plus 5 on the left-hand side is equal to both the positive and negative square root of 45. Now, the square root of 45 can be broken down. We know 9 times 5 gives me 45. And of course, the square root of 9 is 3. So we can rewrite this as x plus 5 is equal to both the positive and negative 3 square roots of 5. Last step, get the x by itself by subtracting 5 from both sides. So our answers, because remember, this does represent two different values, -5 plus and minus 3 square roots of 5. Remember, that does represent two different answers, -5 plus 3 square roots of 5 and -5 minus 3 square roots of 5. Any questions on this example? I'm gonna do another one because I feel like we'll probably benefit from a little more practice. All right, still solving by completing the square. This time we're given the quadratic x squared minus 4x minus 14. And this expression is equal to 0. All right. So if we're solving by completing the square, first thing we need to do, take that constant term here, -14, move to the other side of the equation by adding 14 to both sides. So now I have x squared minus 4x. I'm going to leave space for that number that I'm going to introduce to force it to be a perfect square trinomial. It's going to be equal to 14 plus that exact same number to keep the equation balanced. Remember, the way that we get that number that we're going to introduce is by taking that b term, or the term in front of the x, dividing by 2, and then squaring it. This time my b term is -4. I'm going to divide it by 2 and square it. We know -4 divided by 2 gives me -2. So the number that we're going to add to both sides of my equation to make it a perfect square trinomial will be +4. Right. So we're going to put +4 on both sides to keep the equation balanced. Remember, this changes the way that the equation looks, but it does not change the value of x. All right. Now, because we already know what to expect here, the completely factored form here of the perfect square trinomial x squared minus 4x plus 4 will be x minus 2 quantity squared. Now, if you want, you can go through the process, ask yourself, what two numbers can I multiply to get me +4? That can combine to get -4. Those numbers, -2 and -2. But x minus 2 times x minus 2, by definition, is x minus 2 squared. So this is why I was saying, if you can recognize that step right before we end up finding that number that we need to add to make it a perfect square trinomial. That number inside that parentheses is always going to be attached to the x in a completely factored form. So that can save you some time. And because we're all human in here, enough opportunity to make a mistake, we will make one. This can cut down on that opportunity. This is equal to 14 plus 4, which we know is 18. Now we have a simple quadratic we can solve. Next step, take the square root of both sides. That's going to leave me with x minus 2 on the left-hand side. And we have both positive and negative square root of 18. We do have a perfect square that can go into 18. It's going to be 9. So this really breaks down to 3 square roots of 2. So it's really x minus 2 is equal to both the positive and negative 3 square roots of 2. Last step, get the x by itself. I'm going to add 2 to both sides to isolate that x. So our answers end up being 2 plus and minus 3 square roots of 2. Keeping in mind, this does represent 2 different answers: 2 plus 3 square roots of 2, and 3 minus, and 2 minus 3 square roots of 2. All right. Any questions on the technique for completing the square? All right, next way for us to solve quadratic is using the quadratic formula. This is a reminder. Quadratic formula: negative b plus and minus the square root of b squared minus 4ac all over 2a. Remember, we get the a, the b, and the c by looking at the general form for a quadratic: the number in front of x squared a, the number in front of x b, the number by itself or the constant term will be c. All right, so if we're given the quadratic x squared plus 6x minus 3 is equal to 0, first things first, we need to label our a, our b, and our c. So here my a is the number in front of the x squared term, 1. My b, the number in front of the x term, 6. My c is the constant, or the number by itself, which in this case will be negative 3. All right, so now all we have to do is plug everything in its appropriate place into the quadratic formula and simplify. So if x is equal to negative b, or negative 6, plus and minus the square root of b squared, or 6 squared, minus 4 times a, which is 1, times c, which is negative 3. This is all being divided by 2 times 8, which we know is 1. All right, so this is going to give me negative 6 plus and minus the square root. We know 6 squared is 36. Minus 4 times 1 is 4, times negative 3 will give me negative 12. So we're subtracting a negative 12. And it's all still being divided by 2, because we know 2 times 1 is 2. But anytime we subtract a negative, same thing as addition. So it's going to leave me with negative 6 plus and minus the square root of 36 plus 12, which we know is 48. Still being divided by 2, but the square root of 48 can actually be broken down. 16 times 3 will give me 48. So this breaks down to 4 square roots of 3. So now we have -6 plus and minus 4 square roots of 3 divided by 2. And we always want to look to simplify if possible. Remember, if we have a summation or a difference in our numerator, the only way that we can simplify is to find a number that can go into all 3 coefficients, the 2 in the numerator and that one in the denominator. Here we actually do have one. 2 goes into both 6, 4, and 2 itself. So our final answer ends up being -3 plus and minus 2 square roots of 3. That is technically -3 plus and minus 2 square roots of 3 over 1, but anything over 1 is itself. So this is our final answer. Keeping in mind, this does represent 2 separate values, -3 plus 2 square roots of 3 and -3 minus 2 square roots of 3. All right. Any questions on that? Still using the quadratic formula. This time, we're given the quadratic 4x squared minus 3x plus 5. So this time my A is 4. My B is -3. My C is +5. I'll plug everything into its appropriate place in the quadratic formula. So we're gonna have a negative B, or in this case, a -3 plus and minus the square root of B squared, or in this case, -3 squared, minus 4 times A, which is 4 times C, which is 5. And all of this is being divided by 2 times A, or in this case, 2 times 4. All right, so we know a -3 is just going to be a +3. Plus and minus the square root. We know 3 squared, or excuse me, -3 squared, +9, minus 4 times 4 gives me 16. 16 times 5 gives me, note said 80. Somebody check that for me. I don't know why I don't trust that. 16 times 5. Anybody have a calculator on them real quick? It is -8? All right, appreciate you. And this all this is just being divided by 2 times 4, which we know is 8. All right. Now 9 minus 8 is going to give me a negative number. Remember in the last section, we went over complex values or imaginary numbers. So this is going to give me 3 plus and minus the square root of -71 all over 8. 71, while it's not a perfect square, it also does not break down. The only thing we could do is pull out that I to get rid of that negative, and I already can't. So our final answer ends up being 3 plus and minus I times the positive square root of 71 divided by 8. So remember that when we're using the quadratic formula, that does not discount the fact that we could still get complex solutions, or solutions with imaginary numbers or I's. All right. Next thing we can cover is cubic equations. And the way that we're going to recognize cubic equations is that we'll have 2 perfect cubes, either being the sum of perfect cubes or the difference of perfect cubes. Now, there is a formula for the sum and difference of perfect cubes, but we actually have a method the way you don't have to commit that formula to memory. Right? But a good example for this one would be x cubed minus 8 is equal to 0. All right. Now, when we say perfect cubes, an example of that, obviously x cubed is a perfect cube because, I mean, the word cube is in its name. But x cubed, a cube root of x cubed would be x. This is because x times x times x is x cubed. So this is really x to the third power. And 8 is really 2 to the third power, 2 cubed. This is because 2 times 2, 4. And of course, 4 times 2 gives me 8. So here we have the difference of cubes. Whether we have the sum or the difference of cubes, the completely factored form is always going to be a binomial times a trinomial. The completely factored form is going to have 2 elements in the first parentheses, 3 elements in the second parentheses. Now, whenever we're dealing with cubic equations, you want to remember that the name of this method is called the SOAP method. You also want to remember square, multiply, square. So SOAP is an acronym representing how we get our signs in the completely factored form. SOAP stands for same, opposite, always positive. So the first sign in our binomial is going to be the same as the sign given to us in our question. So we started with a negative, our answer starts with a minus sign. The second sign is always going to be the opposite. So if we started with a minus, second sign is going to be a plus. Third sign, always positive. So this handles all of our signs in the completely factored form. Now we want to fill in that first binomial by taking the cube root of our original problems. This is for each element. So the cube root of x cubed is just going to be x. Cube root of 8 is going to be 2. All right, so this is where that square multiply square comes into play. We're going to use square multiply square to fill in this trinomial with the missing elements. So square, or the first square in this little saying, means that we're going to take the first element in our binomial and square it. So it's going to be x squared. Multiply means we're going to take both of these elements in our binomial and multiply them, ignoring the sign. So x times 2 gives me 2x. And we know this 2x is positive because we use SOAP to get that second sign. Now our last element, we're just going to square the second element in our binomial. So we're going to have 2 squared, and we end up with 4. All right, so this is completely factored. Now we can take advantage of the zero product property, taking each factor, setting it equal to 0, and then solving. So we know one of our solutions is going to be positive 2. In order for us to get the solutions to this quadratic in a completely factored form, we're going to have to use the quadratic formula. And I can tell you now our solutions will be complex. And that's pretty much standard whenever we're doing cubic equations, because if this could be factored further, it would be. All right. So here my A1, B2, C is 4. And now we're just going to plug it into its appropriate place in the quadratic formula. So we have negative b, or negative 2, plus and minus the square root of 2 squared minus 4 times 1 times 4. All this is being divided by 2 times 1. So it's going to give me negative 2 plus and minus the square root of 4 minus 16, because 4 times 1, 4 times 4 gives me 16 over 2. Four minus 16 gives me a negative 12. So now we have negative 4 plus and minus the square root of negative 12 over 2. We can pull out our I to get rid of the negative, and the square root of 12 can be broken down. We know 12 is really 4 times 3, so we can pull out a 2, keeping the 3 underneath our radical. So now we have -2 plus and minus. Two I square roots of 3. All this is still being divided by 2. We have a summation and a difference up top. We do have a number that can go into all 3 of these coefficients. That number is 2. So our final answer ends up being -1 plus and minus I square roots of 3. Now technically this is over 1, but remember anything over 1 is itself. This represents 2 separate solutions, -1 plus I square roots of 3 and -1 minus I square roots of 3. What you mean?
Like the x minus 2, that part, is that this?
Oh, you are absolutely right. What she said was I forgot about this first solution, and that is a part of our solution set. So we actually have 3 solutions to -1 plus I square roots of 3 and -1 minus I square roots of 3. So just to be clear, x is equal to 2, -1 plus I square roots of 3, and -1 minus I square roots of 3. Appreciate you. All right. Any other questions on this one? Though? All right, so we did the difference of cubes. We need an example with the sum of cubes. And we're going to see how those are very similar. All right, now the method to solving these is exactly the same. You just have to pay attention to the signs. All right, so if we have x cubed minus 125 is equal to 0. All right, so the way I want you to think of this, one, we have 2 perfect cubes. Obviously, x cubed is a perfect cube. 125 is really 5 cubed. 5 times 5, 25. 25 times 5 gives me 125. So this one's a good candidate for the SOAP method. Remember, that's for the sum and difference of cubes. Remember, square multiply square. And notice that every time I'm doing this, I write out SOAP and square multiply square. If you do it enough, you don't have to try to remember it. It become a habit to where you can't forget it. All right, remember, we use SOAP method for sum and differences of cubes. Remember, my answer always going to be a binomial times a trinomial. Just check if I understand it. What's going to be my first sign? Negative. Second sign? And last sign is? All right. First element of my binomial, cube root of x cubed. It's going to give me x. Second element of my binomial, cube root of 125, which we know is 5. This is when we're going to use our square multiply square. First element, x squared. Going to multiply to 2. X times 5 gives me 5x. Last element, we're going to square the second element of my binomial. 5 squared, we know, is 25. So one of our solutions right off the bat, we can take the factor x minus 5 set it equal to 0, and we know 5 is going to be one of our solutions. We use the quadratic formula to find the solutions for the quadratic, x squared plus 5x plus 25. So here my A, 1. My B, 5. My C, 25. All right, plugging everything into the appropriate place. We're going to have negative B, or -5, plus and minus the square root of B squared, or 5 squared, minus 4 times 1, which is A, times C, which is 25. Now, all of this is being divided by 2 times A, or in this case, 2 times 1. All right, so we're gonna have -5 plus and minus. The square root, we know 5 squared gives me 25. Minus 4 times 1, 4 times 25, which will give me 100. Well, it's still being divided by 2 times 1, which we know is 2. -25 minus 100 gives me -75. So now we have -5 plus and minus the square root of -75 over 2. The square root of -75 can be broken down. We know to get rid of the negative, pull out an I. The square root of 75 is the same as 25 times 3. We know square root of 25 is 5, so we can pull out a 5. So it's going to give me -5 plus and minus. We pulled out that I to handle the negative. The square root of 25 is 5. We still have that 3 underneath my radical. All of this still being divided by 2. All right. Now, like I said before, if we have a summation or a difference up top, which we actually have both here in our numerator, to reduce, we have to have a number that goes into all 3 coefficients. We actually do not. So we have 3 solutions. Remember, the very first solution was +5, and this represents 2 solutions. -5 plus 5i squared root of 3 divided by 2, and -5 minus 5i squared root of 3 divided by 2. One more, because I don't think I did one with a plus. So let's try x cubed plus 27 is equal to 0. Obviously, x cubed is a perfect cube. 27 is a perfect cube because this is 3 cubed. 3 times 3, 9 times 3 gives me 27. So we're going to use the SOAP method. And square multiply square. My answer, was a binomial times a trinomial. Just check if I understand it. What's my first sign? Second sign? Last sign is always positive. All right, so remember, SOAP stands for same, opposite, always positive. Started with a plus this time. I'll start with plus. Second sign is always the opposite. Last one's always positive. And now we're going to take our cube roots for each element in our original problem. The cube root of x cubed, x, cube root of 27, like we said before, was 3. So we're going to use our square multiply square. So we're going to square our first term in our binomial, x squared. Multiply the 2 terms, x times 3 gives me 3x. Then we're going to square our last term, 3 squared gives me 9. So we complete the factor form, x plus 3 times x squared minus 3x plus 9. So we already know one of our solutions is -3. I'm going to use the quadratic formula to solve the quadratic x squared minus 3x plus 9. Here are my A, 1, B, 3, C, 9. I'm sorry. Be sure to keep the sign. My B is -3, not just 3. Plugging everything into its appropriate place in the quadratic formula. We're going to have a negative B, or -3, plus and minus the square root of B squared, or -3 squared, minus 4 times A, which is 1, times C, which is 9. All this is being divided by 2 times A, which is 1. Just breaking it down, -3 It's gonna give me positive 3 plus and minus the square root. We know 3 squared, or excuse me, negative 3 squared gives me 9. Minus 4 times 1, 4 times 9, 36. All this is being divided by 2. By 9 minus 36 gives me a negative 27. So now we have 3 plus and minus the square root of negative 27 over 2. And outside of pulling out the I to account for the negative, that 27, well, there's a perfect square that goes into 27. Obviously 9 times 3 will give me 27. So we actually can break that down a little further. So now we have 3 plus and minus 3i times the square root of 3 all over 2. We don't have a number that can go into all 3 of these coefficients. Both 2 and 3 are prime. So this represents 2 of my final answers. 3 plus 3i squared root of 3 over 2. 3 minus 3i squared root of 3 over 2. And of course, we already had negative 3. That's one of my solutions. Any questions on the SOAP method? Y'all keep in mind that when it comes to these quadratics, and remember, the test is multiple choice and your homework is on the computer. If you have the calculator, it is a good idea to go ahead and use the calculator, be it a TI or a Casio, to plug in the A, B, and C into the quadratics, so you can kind of cut down that drudge work. All right. Next thing we want to talk about is the discriminant. We're going to have problems involving the discriminant in the homework for this section. Remember, we use the discriminant to find the number of solutions. All right, so whenever we're using the discriminant, we're not trying to figure out what the solutions are per se. We just want to know how many solutions we're going to have. All right, so the discriminant, usually signified with a capital D, is equal to b squared minus 4ac. Or it's going to be the part of our quadratic formula that's underneath the square root symbol. Now with the discriminant, if my discriminant is positive, or if the discriminant is greater than 0, we have 2 real solutions. If the discriminant is equal to 0, then we have 1 real solution. And the discriminant is negative, or if the discriminant is less than 0, then we have no real solutions, but we do have 2 complex solutions. All right. So obviously the question would be how find the number of solutions, and we're going to be given the quadratic. For this example, we're going to be given 4x squared minus 12x plus 9 is equal to 0. So here my A is 4, my B, negative 12, my C, positive 9. All right, so we're going to use the discriminant to see how many solutions we have. So formula for the discriminant, b squared minus 4ac. or in this case, we have negative 12 squared minus 4 times 4 times 9. Negative 12 squared, or negative 12 times negative 12, gives me 144. Minus 4 times 4, 16. 16 times 9 gives me another 144. So my discriminant is equal to 0. How many solutions do I have? One what? One real solution. All right, any questions on that example? All right. Still using the discriminant to find how many real solutions we have. Here, we have 2x squared minus 6x minus 7 is equal to 0. So here my A is 2, B negative 6, C negative 7. So to find my discriminant, we're going to have a B squared, or in this case, negative 6 squared, minus 4 times A, which is 2, times C, which is negative 7. Now, provided we place the calculator correctly, what we should get is 92. What we're really interested in is if it's positive. Obviously, this is a positive number, and if we subtract a negative, it's going to give me a positive. So we're going to have 2 real solutions here. The last example for this one, given the quadratic 3x squared plus x plus 5 is equal to 0. Here my A is 3, B is 1. Sorry about that. And C is 5. Still using our discriminant, which is B squared, or in this case, 1 squared, minus 4 times A, which is 3, times C, which is 5. So we end up with 1 minus 60, which is obviously a negative number. More specifically, we end up with negative 59 for our discriminant. So we end up with 2 complex solutions. That's our answer. The last type of problem we're going to have in this section is when we're working the problem backwards. Instead of us trying to find the solutions, given an equation, we're going to be given the solutions and finding the equation itself. All right, so given solutions, x equals negative 3 and 2. Write an equation that satisfies this. So what we have to remember is that if we have factors, the opposite of what we see in our factor is our solution. So if they're given solutions, we just take the opposite of what we see in our solution to create a factor. All we have to do is put x in front of it and obviously put it inside of a parentheses. So if negative 3 is my solution, that means that our factor, or at least one of them, is x plus 3. And if positive 2 is my solution, then our factor, or at least one of them, is x minus 2. Now to get that equation, well, one, we need to get the expression by folding it out. Then we can zero it out to get an equation. So we're going to fold this out. X times x gives me x squared. X times negative 2 gives me a negative 2x. Positive 3 times x gives me a positive 3x. And positive 3 times negative 2 gives me a negative 6. And combine all like terms, of which we have 2, negative 2x and positive 3x. So this gives me the expression x squared plus x minus 6. And we can zero it out to get an equation that satisfies the solutions, negative 3 and 2 for x. All right, so our answer ends up being x squared plus x minus 6 is equal to 0. You do want to remember to zero out the equation because that's what we're asked for, is the equation. All right, any questions on this? All right, so remember, this is tied to the homework for 1.4. This will be the last type of problems you see on 1.4. Remember, keep an eye on your email because we had a council class on Monday for 1.5 explaining those word problems. I did assign 1.5's homework for this week. I'm going to go in and have to change some dates because obviously our test date is going to have to change. All right. Remember, I'm always going to give you guys at least a week advance notice and let you know when the test is coming. If you don't have any questions, you guys are free to go. And I'll see you next Wednesday. Is it Monday, Labor Day? Yeah, I'll see you guys next Wednesday. All right. Keep an eye on your email. Have a great day.